Hello and welcome to this video about our parameterizable safety relays 3SK2. My name is Andreas Wiemann and I have been working in the field of functional safety for several years. Today I would like to show you how you can use our software SafetyES version 17 to parameterize our safety relays 3SK2. Afterwards, I would like to show you how you can use our virtual environment SIRIUS Sim to directly test this project. For this exemplary project that I will show you today, I selected an application with an emergency stop and a protective door connected to the 3SK2 safety relay. On the left-hand side you can see the diagram where you can see the slim 3SK2 with 10 digital inputs, where the emergency stop, the start button and the two position switches are connected. Furthermore, you can see on the outside two redundant contactors 3RT, and you can also see the feedback monitoring, which is again connected to the 3SK2 inputs. You can find the link to this application example on the right top of this slide. So let's directly jump into Tier Portal, where I will first create a new project, and after the project has been created, we can then start to put our 3SK2 into the project. You will find the 3SK2 under Control Devices, where you can configure and select the device. While I click here on Add New Device, we will see that there are a few devices available in the SIRIUS portfolio. So there are the motor starters, SIMO code, and under SIRIUS safety relays, we will find the two 3SK2 devices. For our use case, the slim one with 10 digital F inputs is sufficient. If I click OK, we will directly jump into the project view of Tier Portal. Here you can see that the safety relay 3SK2 has been added to the project, and you can furthermore see that there are a few tabs available. We will start with the device configuration. In the device configuration, you can see that there is the basic device currently, and you can see here on the right that you can add other modules, for example the interface modules of Profinet or Profibus, and also a diagnostic display. What we can do here also is, if we mark the 3SK2 and click here on properties, you can do some general properties here, but you can also see that there is a tab for terminal and references. And that is very important for us to then see in the project which input concerns to which emergency stop, for example. So I will start to type here my channels: eStop channel 1, eStop channel 2. We will of course also need the door channel 1 and door channel 2. Of course, we will also need a start button, because our emergency stop will get a monitored start, so that the machine does not run automatically if someone releases the eStop. That's why I will give a start button here, and on input 10 in this case, I will connect the feedback monitoring of the contactors. On the output side, we will need two contactors. That's why I will take the F output 1 for contactor 1, and for the second redundant contactor I will take the second output. Okay, that's it for device configuration. Then there is online diagnostics. That's what we will not need today, as this is for a running project or a running machine to, for example, find errors in the machine. Next step will be parameters. Before we can start with the project itself, we need to create some project data here. Under identification, if I scroll down, there is some project data here, and this is necessary to successfully compile the project later on. So that's why I will just type in some default data, and next step here is commissioning, but commissioning of course will just take place when we have then fixed our project and can do the commissioning with the simulator. For us now it's important to do the charts. Why I add new chart? I can directly add a new chart and the blank sheet will open in a second. You can see on the right hand side that there are several function blocks available. For our emergency stop, we will search in monitoring functions and you can see that there is a certain function block available for the emergency stop. You can now see that it is single channel. That's why we need to go here into properties and parameter, and here you can see that we can switch to double channel NC, and then we can connect the inputs. You can also see that here our terminals or our terminal names can be found here. So we take eStop channel 1 and 2, and furthermore we will of course activate the cross-circuit detection. If I scroll down a bit, we can also change the type of start to monitored. You can see that there is a new start input here, and that's why we will need an input function or an input cell here, so that our start button can be connected to the emergency stop. Via drag and drop, you can always connect the lines between two blocks. Again, I mark the input cell to create here the right input, the start button in this case. Okay, so far so good for the emergency stop. Now we will need protective door monitoring, and you can see that there is also a perfect function block here available called protective door. I will again add this one, and in the properties we can again find the parameters, where we will of course change over from single channel to double channel NC, so normally closed, and we can then connect the inputs, in this case input 3 and 4 for the two door channels. Of course, we will also activate the cross-circuit detection for the protective door monitoring, and we will not change the type of start, because here I would like to have an automatic start, which means that if someone closes the door, the motor can start automatically. This is only allowed when no one can stand behind the door if there could be a dangerous situation. Okay, we have now the protective door and we have the emergency stop. Of course, we will now need an AND functionality, which can be found underneath logic operations, because only if both the emergency stop and the protective door are okay, the motor should run via the two redundant contactors. Again, via drag and drop, I can connect the three blocks, and then we just need another function which is called output function, can be found here at the bottom, switching output and the F output. Again, we will need to do some parameterization here. We will change from single F output to redundant, as we have two redundant contactors here. We can activate the feedback circuit monitoring, in this case to off and on status. That means that we can both see when the contactor is switched on, if it has really switched on, and if we switch it off, we can see if it has really switched off. I will also change a bit the feedback circuit time, because for the simulation we will need a bigger range for the feedback circuit time. If I scroll down a bit, we can then connect the two outputs, contactor 1 and contactor 2. If we have a look at the sheet, we can see that again we have two inputs here. The input connected to the AND module is quite clear, I guess, and there is the feedback input, and here again, just like with the reset button, we need an input cell where we can then choose via the parameters which input should be addressed here. It's the input 10 for feedback monitoring. And then again, a last drag and drop to the feedback. And that's it. As we have now finished our project in SafetyES version 17, we can now jump into the next step, which is the verification or test phase. Here we differentiate between hardware on the left-hand side and simulation on the right-hand side. On the left, you can see our 3SK2 demo case. It can be used, of course, to test the functionality, and in your case, if you have the 3SK2 hardware already available and already on your desk, you can start to wire and test the whole project. Obviously, it is much faster if we do it in the virtual environment. That's why I will now show you how to do it with the SIRIUS simulator, and you will see that we will be much faster. As a result, of course, we can see that we will get a much quicker time to market. If I open the software SIRIUS Sim, I will get to this entry page here. At the top, you can see a few application examples. First here for the product family of the soft starters 3RW55, but also for the product family of 3SK2. You can find 7 application examples. And that's the first use case of the software. You can get in touch with the 3SK2 if you have never worked with it before. You can see how it works, how it reacts to certain applications, and so on. For us, it's now used to test our project. That's why I will create an own project here via the plus symbol. And you can now see that we have here again hardware catalog. There we will find the basic units, and I will now add the slim 3SK2 module to the blank page. You can see it's a real picture with the 10 inputs and the outputs of the 3SK2, and you can also see that you could add more modules just like within the SafetyES project, for example the Profinet interface, or also output expansions like 3RM1. If I now start the simulation, you will see that the device is booting, which you can see on the blinking LED here. The yellow state of the LED shows us that the device is in configuring mode and is now ready to have a download from SafetyES. For your background, the 3SK2 here in the virtual environment is behaving exactly the same way like the real hardware would, because the firmware of the module is really running on my PC right now. Okay, we are ready now to jump back into Tier Portal, where we can now select our Safety Relay 3SK2 and press here the Download to Device button. By that, a window will appear where we will first need to do some selection on the type of PIGI PC interface. You can see that we have here 2 possibilities: SIRIUS P2P, that means point to point. This is the USB cable connected to the real hardware. We also have the possibility to do it via Ethernet if we would have added a Profinet interface module. In this case, we will choose the SIRIUS Sim connection. Via Start Search, the SafetyES version 17 project is now looking for devices in the virtual environment, and you can see that it has already found one. We can now click on Load, and by that the loading process is started. You can see that there is a compiling running. We can get here some information on the capacity of the device, and again I click on Load, and then the project which we have created minutes ago is now loaded down into the virtual world, into the SIRIUS simulator. By the way, the SIRIUS simulator can be downloaded for free in the SIRIUS online portal. You will get the link later on in my slides. So just wait a few minutes and I will show you where you can find it. Okay, the loading is now completed with 0 errors and 0 warnings. We can now jump back into the simulator. The first thing that we can see in the simulator is the state here at the right top. We are connected to SIRIUS ES, so everything's fine here. The 3SK2 module here has now the project inside itself, and now it's up to us to add all the switches, push buttons, emergency stops and contactors. But our SIRIUS simulator offers a new possibility. You can now automatically generate these modules. That's why I will now stop the simulation. And if I scroll down here a bit, we can create here options. It says, with the following feature, it is possible to create peripheral elements automatically based on the engineering data. So I click on Create Now, and you will see that it has automatically recognized that there is an emergency stop connected to input 1 and 2, and also a protective door double channel to 3 and 4, and it has also recognized the start button. What is still missing is the output side. Here I will add one single contactor. Yeah, I know we have actually created a redundancy here, so 2 redundant contactors, but in this case this is absolutely sufficient to see if everything works the way it should, and we can also use the Q1 here for the feedback monitoring. Okay, so then we will connect to output 1, and I will also connect the Q1, which is the mirror contact of the contactor, to input 10. If you remember, this was the input where we realized the feedback monitoring. Okay, then we will again start the simulation, and the device is booting. It says yellow LED, which means configuring mode. So far so good. I will now change back into Tier Portal because we can now here do the commissioning. That's why I will click on the tab Commissioning here. And what we will need now is the commands, because we would like to change into test mode from configuring or engineering mode into test mode to see if our project works the way we would like to do it. So let's go online to see if everything works fine. You can see on the bottom right that there is a connection being established right now, and you can also read here connected to the safety relay. In the tab Commands, we can now click on Test Mode. Yes, we would like to activate the test mode. The default password for the 3SK2 is always 0000. You need to change the password here. I will just take 4 times 1 and click on OK. If we have a look at the simulator back, you will now see that it will change into test mode, which we can see here on the blinking green LED. Okay, in Tier Portal, I will now change back into our chart, and then we can here use the monitoring function. By that you can see all the signals. We can see that the protective door already has the check mark here and also sends a logical 1 to the end module. What is still missing is the emergency stop, and we can also see the small signal here which shows a ramp, and that means that the input of the start button is still missing. So let's change back into the simulator and press the start button, and what we can see now is the contactor has switched on, which you can see here on the blue line, and back in Tier Portal we can see that now everything's green and the output is also switched on. So you see, everything's working the way it should, and our project was created perfectly fine. But we can also use the simulator to do, for example, fault implementation. So we can have a look if, for example, our cross-circuit detection on the emergency stop side is working correctly. I can do that via marking the emergency stop, and then we can here activate faults. I will now do the cross-circuit fault, and you will see that the 3SK2 says, well, there's an error somewhere. If I would like to know it in detail, I can now go back into Safety S, where we will see, yeah, here is a red symbol. I can right-click on the emergency stop and here choose the element messages. Then we will get into the online and diagnostics, and you can see that there's a wiring error, and in the detailed element message it says cross-circuited input 1 and 2. So obviously our cross-circuit detection works perfectly fine. To fix that again, I will change back to the simulator and undo the fault here, so no fault selected anymore. The 3SK2 still says it has an error here. That's because we need to do a hardware reset here on the module, because yeah, it's quite a bad error if you have a cross circuit in your machine. So I click reset, it's green again, and I can start the contactors via the start button, which is illuminated here in blue. So you can see that within the SIRIUS simulator it is really easy to do a fast commissioning. You can see if your project works the way it's supposed to, and you can also do fault implementations. And by that you can get very quick to your ready machine, and by that have a faster time to market. To sum it up, SIRIUS Sim with 3SK2 makes it very easy to simulate your safety applications. It is available in SIRIUS free of charge, and you can test the whole functional range of 3SK2. You can get to know 3SK2 with ready-made applications. And furthermore, virtual commissioning is the keyword here. You can create SafeDS projects and can test them with the simulator without any hardware. So no need of real hardware to easy and fast adjust your applications and find errors and so on. By that, it saves a lot of time and costs. The answer is always SIRIUS Sim with 3SK2. And with that, I would like to thank you for your attention and have fun with SIRIUS 3SK2. Bye!